All right, hello once again, Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College Application and Website Development, or AWD1100 1100 Programming Fundamentals with C# course, I've been going through a series of video presentations that I'm doing based on the PowerPoint slides for the textbook we're using for the AWD1100 course. That book being Muroc's C# 7th edition, as you can see on your screen. And so far, I have covered all the material in Section 1, all in Section 2, most of it in Section 3, and all of it in Section 4. So that brings us to Section 5, which is on database programming. Now, when we do this, I've kind of, for lack of better words, I've got two different ways that I can show you how to do this stuff. In the past, I've always used SQL Server. I give a little prelude by talking about my SQL, and then we go into SQL Server. And by and large, people have had problems with it. So I'm going to try something new, and we're going to see whether or not it works. And that is, we're going to start with, I'm going to go over Chapter 19, but then we're going to go over how to do some of this stuff using MySQL. All right. And if you say, I don't know what any of that means, you don't have to worry about it, because it's all going to be explained, or hopefully it'll be explained in the next coming minutes. So I'm going to start by jumping into Chapter 19. There are only 26 slides on here. When I get done with Chapter 19, I'm going to jump into an article that I found online in C# corner that's called C# Connect to MySQL in Visual Studio 2019. So we're going to go over, hopefully at least both of those, in our talking here about Chapter 20. So, as always, as we start here, we've got our cover slide, which is an introduction to database programming. It would easily be possible to create an entire C# course just on databases. We don't have one, but you're getting it towards the middle to 2/3 to end of the semester in here. All right. So on the next page here, we've got our knowledge objectives. Describe the hardware components of a typical multi-user system. Describe the software components of a typical multi-user database app. Explain how table data is organized. Explain how tables are related. And describe the major SQL statements, those being select, insert, update, and delete. Now, this is an interesting picture, because this is a typical picture that they will put into a Muroc textbook. Now, that said, why does that make it an interesting picture? Because over time, it has changed. Where they're showing client there, that's a user's computer. That could potentially be a laptop, a desktop, a tablet, a phone, or even something else. All right. And in the past, basically, they Muroc almost always showed this as being a desktop or a laptop, but now it's not necessarily. So as it says, the clients are the PCs or workstations of the system, and typically they are going to be a PC, a personal computer. The server is a special computer that stores files and databases and provides services to clients. When it stores databases, it's referred to as a database server. Now, think about this. If, for instance, I were to go out right now to Amazon.com, all right, and let's just suppose, I don't know why I'm getting this stuff, I've never bought any clothes from them, but a lot of times when I go out here, okay, what'll happen is Amazon will remember things I've looked at in the past. Doesn't look like it is now, but it'll, basically look at things that I have looked at in the past. I want to look at that later for my granddaughter. All right. But it says inspired by your browsing history. Well, I got sent this thing about this bone broth cookbook yesterday, which I guess I'm really not interested in. But since I clicked on a link, it's got that. Now, some other stuff it may or may not show me. I don't know. Other things connected to that, other products connected to bone broth, etc. But maybe you've done this kind of thing before. I know I have. And that is, I've come out here and let's pretend for a moment that what I want is I want to go through the books and I want to put in something like C sharp, whoops, C sharp with C sharp with SQL Server. All right. And notice what it has here. Practice C#.net and SQL Server. It's going to have a bunch of other stuff in here. SQL 3 books in 1. Learn SQL quickly. SQL Server with C#. All right. And there'll be a bunch of these. Okay. Now, if I go back here again, there's at least a chance that either now, right now, or if I get out, so if I get out here and get back in again, so if I get out and get back in again to Amazon, well, it still has the ones here from my browsing history. But the point is this. Amazon, when you think about it, they have, I would guess, hundreds, if not thousands of servers. Many of their servers are going to be responsible for keeping histories of Amazon clients. Those histories are being saved in databases. I can virtually guarantee that that's the way that it is. All right. Now, they also mentioned in here that the network consists of all the cabling, the communication lines, and the other components. Well, with the network, this could just be the cloud. For instance, I'm here at Rankin Technical College in Wentzville, Missouri. All right. If I go into we're in the Taylor building, the T building. If I go into T203 or into T201, which are the two laboratories or labs that we have for information technology classes, all of those computers are literally wired together. They are in what's called a local area network. There is a physical connection between them and some of the other machines on campus. On the other hand, I am approximately 40 miles from St. Louis. And St. Louis has similar types of labs over at their campus, but their labs and the labs here at Wentzville are not physically connected. You would have to be running cable or something underground for like 40 miles to do that. So rather than doing that, rather than having a local area network where there's a physical connection, we have what's called a wide area network or a WAN, where they're not physically connected with one another. All right. So if you've got a simple client server system, it says the server is typically a high-powered PC. It communicates with clients over a LAN. I have just mentioned that to you. The server can be a desktop, it can be a mainframe, it can be a lot of different things. A client server system, as mentioned there, can also consist of one or more PC-based systems, typically known as an enterprise system. And as it says, individual systems that can be connected and share data over private networks, such as with a WAN. Okay? All right. Now, I don't expect this slide right here to make total sense. And if it doesn't, it's totally fine. But what I want you to understand, if that's me and that's Amazon, all right, if I make a request to Amazon, it's probably not, repeat, probably not going to a database server. Rather, it's just going to some more general purpose server that if it decides it needs to go to a database server, it will. All right. But when I go in and ask for a book, a lot of things have to take place, such as, well, Amazon has got to check and see if that book is in stock. All right. It may want to come back and tell me, hey, you're ordering this book, but just so you know, there is a more up-to-date edition available. So there's a lot of different components that go on in here. It's more complex than what they're making it look like in this picture, in other words. To manage a network, the server runs on a network operating system like Windows Server. To store and manage databases, each server requires what's called a DBMS, or a database management system. Two of the ones that are used most often, and there's more than this, but two of them are Microsoft's SQL Server and Oracle's MySQL or MySQL. The processing done by the DBMS is typically referred to as back-end processing because you don't typically see it as an end user. All right, it happens on the back end. All right. The application software, as it says, does the work the user wants to do. The data access API or application program interface is the interface between the application and the database management system. As it says here, Microsoft's data access API is ADO.net. ADO is an acronym for ActiveX Data Objects, which is part of .NET. What you see on the client side, or what I see when I go out to Amazon, is the front end. As it says here, the application software communicates with the DBMS by sending SQL queries through the data access API. When the database management systems receives a query, as mentioned right there, it provides a service. It does something. It typically returns data that has been requested by the client. Now, since really probably a good 50 years ago, kind of the premier database language that has been used has been SQL, structured query language. And there are structured query language variants for MySQL, for SQL Server, for Oracle, for Postgres, etc. A lot of these different DBMSs. What is starting to become more in vogue today than using SQL or structured query language is to use what's called Nosql. Now, Nosql does not mean there is literally NoSQL. The NO that's in there stands for not only. So it's not only structured query language. All right, they're going to work in here with this products table. We'll take a look at it in just a bit. All right. You'll notice that this products table right now looks as though it has 4 different fields in it. It has a field called product code. It has a field called description. It has a field called unit price. And it has a field called on-hand quantity. Now you can see if you look at this that the first 2 fields, the product code and the description, are more textual fields. They're strings. They're literally what you refer to in most database SQL languages as varchars, V-A-R-C-H-A-R, meaning they're variable length character fields. This field is a decimal type of field because it has a decimal point in it, or a double field, depending again on what SQL variant you're using. And this would be an integer or a whole number. All right. So before we even go into this, I'm going to leave this up here. But I'm going to do this. I'm going to give you some definitions. All right, I'm going to start with this. So what is a character? Character. And I'm going to define it right now as any keyboard character. All right. So any number, any letter, any special character. All right. If you put one or more related characters together, you get what's called a field. So you could have a field called first name. In my case, it would hold Jeffrey because Jeffrey is my first name. All right. If I take one or more of these related fields and put them together, I get what's called a record. Now, if you remember from what we talked about in the previous chapter, we had pretty much a record where we had the first name, the last name, and the department. So that consisted of 3 different fields. So each record had 3 fields. If I go and add one or more related records together, I get what's called a table. All right. And what's big about that? Because what a database is it's one or more related tables. Now, these are my definitions. You're not going to exactly find them in most books. All right, so what does that have to do with anything? Well, let's knock this down and take a look at what's in here. We're going to be working in this course with a relational database, or maybe even 2 different types of relational database management systems. As it says, a relational database uses tables to store and manipulate data. All right, well, you can see on here what records are. You can see what tables are. So a table, as it says, consists of one or more records or rows that contain data for a single entry. Each row contains one or more fields, also known as columns, with each column representing a single item. Now, most tables contain what's called a primary key. Now, why is that important? Let's keep it simple. That is a unique record identifier. And if I asked you, how do you think you're identified in most places, you'd probably say something like my social security number, and you'd be right. That said, what you should strive for when you are working with databases is to have a primary key that is what is referred to as being unintelligible. What does that mean? Well, you probably all know this already, but if somebody were to get a hold of my social security number, they could potentially do damage to my credit history, to my name, etc. They could try to open up accounts here and there. They could try to do all sorts of things. So if my primary key is my social security number, that's not a good idea, because rather than that being unintelligible, it's intelligible. If somebody guesses that or figures it out or whatever, all right, there's a lot they can do and find out about me. On the other hand, if I were to come in here and make a field called ID, and it was just a number field. So if there were those 7 instructors from Black Hawk and Charles Corrigan was number 1, etc., and we did it like that, all right, then if somebody found out that Charles Corrigan is number 1, who cares? So that would be an unintelligible ID. All right. Some database management systems let you have one or more non-primary keys. In fact, quite often those are referred to as candidate keys. Let me give you an example. All right. At Rankin Technical College, I think, and I could be wrong about this, but I think that basically students and faculty and staff alike, our primary key is probably our social security number. But you know, as students, you also get a Rankin number that's associated with you. All right. And potentially either the primary key or, so either potentially the primary key or, I should say the social security number or the Rankin number could be used potentially as primary keys. They're each unique. All right. Tables can also have indexes. And an index helps when you are querying or asking a database for information. Now, many times people get confused over things like indexes, but just imagine that you have the Muroc C# 7th edition book right in front of you. And I ask you what primary key is, and you say you don't know. You might turn to the back of the book and look under the P's and try to find primary key. So you'd look in the index. And really, internally, indexes for a database work in a similar yet not identical way. All right. Now, we talked before about how a relational database uses tables. Notice tables plural. Well, here's two tables. All right. The first table has all sorts of information about invoices. And the second one that's here has information about the items that make up those invoices. So notice we've got here as an example invoice ID, and if we look at 46, you'll notice that's customer 20. It was on this date. The total was this amount of sales tax. This is for shipping. This was the invoice total. But what made up that invoice? The answer is this 1, 2, 3, or these 4 different things. So we have two tables, all right, that are somewhat at least referencing the same information. How can they do that? You'll notice that both tables have in them an invoice ID. Here, the invoice ID for this invoice, this would be the primary key. It would be a single field that would make up the primary key. Here, notice we've got 46, 46, 40. You cannot use invoice ID for the primary key for the unique record identifier because 4 are the same. But if I make what's called a concatenated primary key and I combine 46 and ASP Web, 46 in C#, 46 in HTML, 46 and SQLS, all right, now they are unique. So it's totally legitimate to have a primary key that's more than one field. And we could use that then and be able to relate these tables together. So if somebody said, I want to know all the information about invoice ID 47, well, you could tell the customer associated with it. You could tell the date the invoice took place. You could tell the product total, the sales tax, the shipping costs, and the invoice total. But if you wanted to know what was in there, you would have to take that information and basically combine it with information from the other table to know that there was a book called ASP Web and another one called C#. All right. And there was one ASP Web ordered and 4 different C# ordered. How are the tables in a database related? Well, I just kind of showed you that. This is the primary key here. These two are combined primary keys here. Basically, since we've got a field in common, this would be the parent table, the invoices table. This would be the child table, the invoice line items table. When you take the primary key from the parent and you add it as a field in the child table, it's what's known as a foreign key. As it says there, usually a foreign key corresponds to the primary key in the related table. When two tables are related via a foreign key, the table with the foreign key is called the foreign key table, and the other one is called the primary key table. Also referred to other names like parent-child tables, etc. The relationship between the tables in a database correspond to the relationships between the entities they represent. There are three basic types: one-to-many, one-to-one, and many-to-many. The nirvana, so to speak, when working with databases is you'd like to have all of your relationships be one-to-many. So every one in one table would be related to 0, 1, or more in another table. That's what you're shooting for. Now, when you get a one-to-one relationship, so I'm going to show you this real quickly. I'm going to give you another example here. So let's go to where we looked at this here. I'll just leave this stuff here, but I'm going to hit enter quite a few times here, so this kind of goes off the screen. All right, so let's imagine that I've got one table, and let's say that it has an employee number, and let's say it's got an employee first name. It's got an employee last name. It's got an employee address. It's got an employee city. It's got an employee state. It's got an employee zip code. All right. And now we start saying an employee, how about their department? How about their supervisor? Who do they report to? How about their salary? All right. Well, sooner or later, you reach a point with when you've got one table like this, it's too big. There's too much information to put into it. All right. So maybe what I would do is I would create a second table over here. All right. So this first table I might call personal. And then I might create a second table that's called business. All right. And I'm going to actually put this employee number in both tables. But I'm going to grab the information here, the employee's department, the employee's supervisor, and the employee's salary. And I put them into a different table. So I now have two different tables here. One called personal, and you can see the stuff that's in it. One called business, and you can see the stuff that's in it. It would be totally legit to do what I had done here, and that is put everything into one big table, as opposed to busting it up into two tables. All right. And there may be times you want to do that. But what I have here is a one-to-one relationship. What I mean is each employee has one employee number, one first name, one last name, one address, one city, one state, one zip, one department she or he works for, one supervisor she or he reports to, and one salary she or he earns. But if I take those two tables, if I take that one table and bust it up into two tables, this is a one-to-one relationship because every one record over here is related to one record over here. Well, let's say I add another field, and I call this department number. All right, and over here, In fact, we won't even have department number here. We'll put it over here. Okay. And now, let me move this over a little. I create another table here that's called departments. All right. And now I have in here the department number, and I have the department name. Well, hopefully what you're getting here is, let's say that there are thousands of employees, and I have 6 departments. I'm making this up. So 1 is equal to the information technology department. 2 is equal to the web development and design department. 3 is equal to the programming department. 4 is equal to the accounting department. 5 is equal to the shipping department. And 6 is equal to the receiving. Whoops. Now, you're all smart enough people watching this. Let me cut down the size here a little bit. All right. So when I'm working on this, it would be much easier in this table to put a 6, to put a 3, to put a 1, to put a 2. All right. And in here, I only want a list, so I could put in 1, information technology, 2, web development and design. So I only have to list these terms one time in this table. These numbers can be in here hundreds, thousands, millions of times. All right, and I've got a field in common, so I'm able to combine the information between the two. So in other words, this has got department number, and this has got department number, and they're going to be the same field. That is a one-to-many relationship. Finally, you can have a many-to-many relationship, which is what you don't want to shoot for. You want all the information, all of the relationships you could possibly get in a database to be one-to-many. All right? Occasionally, you may have one or more one-to-one relationships, but when you get a many-to-many, that can't be handled very well by relational database management systems. So instead, what you do is you create yet another table called a jump or a join table. We'll see that in a little bit. All right. Now it says the server design window for the invoices table. This is something when we go in and we look at this, and I think we will probably sooner or later, in SQL Server, it's letting you know that you have 1, 2, 3, 4, 5, 6, 7 fields. Of those 7 fields, the one with the key means it's the primary key. So the invoice ID is the unique record identifier. None of these fields allow unknown or null values. None of these fields have default values. All right. So it's letting you know here what the primary key is. There are no check constraints or indexes. There is a foreign key, which means this is going to relate to a table somewhere else. All right. When you work with SQL Server, really with any relational database management system, you're going to have different data types. They may not all be exactly the same with their names. These are the ones that you have for SQL Server. You get a bit. What's a bit? A bit is a binary digit that can have a value of 0 or 1. Every 8 bits together make up a byte. Every byte is the equivalent of a single character. Then you can have char. Notice there's char, varchar, nchar, and nvarchar. All right, char is a fixed length character field. So if I created a field called state, where I was using the state abbreviation, I could have char2. I already showed you varchar, which is a variable character length field, earlier when we talked about first name or last name. Now, I'm not sure how they or why they added nchar and nvarchar. I've heard stories, and I don't even want to circulate them. I'm not sure why. Date and time are what you think they would be. All right, decimal and numeric. Really, unless a field is something like number of parts on hand, where it has to be a whole number, almost always, unless it has to be a whole number, you will find numeric fields will be decimal or double. Float just means it can have a decimal point in it. Those four types of ints you see right there, big int, small int, and tiny int, those are whole number only. And money are what we have been using pretty much for decimal so far. All right, so they have this database in here. This database is called MMA Books. All right, it has 1, 2, 3, 4, 5, 6 tables in it. A table called customers that is related directly to a table called invoices that is related directly to a table called states. A table called invoices, which is related directly to a table called customers and to a table called invoice line items. A table called invoice line items, which was related directly to an invoices table and a products table. A states table that is related directly to a customers table and an order options table, which is not directly related to any table. Any other table. Now, you'll see that with a bunch of these where they're showing the relationship, there is a key, and then on the other side, it looks like an 8 turns sideways. The key means the one where it's pointing to the key, that's the parent or primary table. The one where the 8 is pointing is the child table. When you want to get information out of a database, all right, when you want to get information out of a database, you do what's referred to as a select statement. When you do the select, some of this looks somewhat familiar to what we saw in the last chapter when we were working on link. The difference is link or line item query will work with databases and will work with non-databases. SQL will only work with databases, so we use the select first. If you put an asterisk after the select, it says select everything. But you don't have to do that. Quite often, you don't want to do that. So you can list one or more column names. From, followed by the name of your table. Where, and you'll notice the where, the order by are they both have brackets around them, meaning that both of them are optional. The where allows you to put in your selection criteria. So if I worked at a school that, let's just say, had 500 instructors in it. It was a very big school. And I said select first name / or comma last name from instructors. It would give me all 500 instructors' first name and last name. But if I said select first name comma last name from instructors where field of teaching equals information technology, rather than having it return 500 results, it might return 5 results. Order by is all done, again, for putting things in ascending or descending order. So here's an example. This says I want the name and the city of all my customers, but only where the state is equal to Washington. Okay. and then order it by name. So all of these cities are in Washington, even Oregon. I didn't know there was an Oregon, Washington. So these are the names, these are the cities, but I want only the ones where the state is Washington to be returned. When you query a table, the results that you get back are known as the results set. Okay? The select clause, as it says there, does not have to, but can include calculated columns. We'll look at that, but not right now. The from clause names the table, or as you'll see later, it can be tables where the data is retrieved from. The where clause, again, is the criteria. If you don't put any criteria in at all, if there's no where statement, it'll just return everything. The order by will order things in an ascending or descending sequence depending on what you ask for. Here is the way that you can join two tables together. I don't expect this to make a lick of sense to you right now, but we will go through examples of it as class. You end up with kind of ugly statements like this, where you are combining information from the invoice line items table along with the products table. All right. Another select statement here with another join. Now here they're using aliases. So rather than calling this invoice line items, it will now be called LI, for example. A join allows you to combine data. Usually it's from two or more tables, but it's from two or more data sources. The most common type of join that you would do would be what's referred to as an inner join. That's where you've got something in one table that matches something in another table. All right? The operations that you can perform on data in a database, there are basically 4 of them. All right? And they are, I'm going to put them right down here. You can select information from a table. When you select it, it's like I ask you to give me something and you give it to me. You can't change it. All right? So it's read only, but you can select any information you want. You can add new information by using an insert. You can update information by using an update. You can delete information by using a delete. All right? These different things that you see in here, all right, they also go by one other name, and that is, rather than select, you'll sometimes see read. Rather than insert, you will sometimes see create. Rather than update, you will it'll be update. And rather than delete, it'll be delete. The difference is these are known in database terminology as data manipulation language, or DML commands. Make this yet a little bit smaller. All right, so those are DML commands. Okay, these are usually put in the order of create, read, update, and delete. If I grab the first letter from each one of these, it comes back as CRUD. All right. There are also, in addition to data manipulation commands, there are a couple, and they are, what do I want here? There is, I can't think of the first one. One is alter, and one is drop. What's the first one? And it's eluding me right now. But they are referred to as the data definition language, or DDL commands. I was going to say it's create, but it's not create. It's well, let's see if we can find it. All right. DML, insert, update, delete. I want the data definition language commands. Create, alter, it is create again. Okay. So that is create. Now, how do you remember these? You don't have to remember them. I've got my own foolish way for these in here. Okay. Well, the way I remember them is the S from select, the T from select, the T from insert, the U from update, the P from update, the I from insert, and the D from delete. So stupid. Select, update, insert, delete. And for the other one, for the data definition language commands, CAD. Create, alter, drop. And I already talked to you about CRUD. So when you do an insert, that's how you put information into a database. When you do update, that's how you change existing information in a database. When you do delete, that's how you remove information from a database. So what I'm going to show you in a couple minutes, and I'm at 48 minutes now, so this has been plenty long enough. What I'm going to show you is a way that we can grab that information that we used earlier, and we're going to talk about how to put it into a database. When I say that information, I'm talking about the information that we used before that allowed us to put in those seven different employees or instructors that we had. All right, so the stuff that we had from, not from here, all right, but that we had Charles Corrigan, Jeff Scott, etc. So we'll look at that in a couple minutes. All right, be back shortly.